how exactly data stored and how exactly data processed. Right? Today I'll be discussing with examples. So Hadoop is meant for storage and processing, for huge data storage and for huge data processing, right? Hadoop providing two services, storage and processing. So it is for batch applications, it is for batch processing, it is not for online processing. Hadoop is not meant for online processing, it is for batch processing. But Hadoop, if it is integrated with NoSQL database, it can also perform online processing, right? Fine. How exactly data stored and processed within Hadoop means? In Hadoop, data is stored in the form of files. Each file is again subdivided into blocks, right? Each block size is fixed one. These blocks are distributed across. I can say it is subdivided into fixed size blocks. Fixed size blocks. These blocks are distributed across multiple slaves and are processed parallelly. Default block size 64 MB, but if you see from Hadoop 2 version onwards, it is like 128 MB. So every file should have dedicated number of blocks. In a single block, no two files data to be stored, right? Tomorrow, if you are retrieving a particular file, so that only that file one related blocks need to be retrieved, file two related blocks need to be retrieved. So that's why every file will have dedicated number of blocks. In a single block, no two files data to be stored. All the blocks will have equal volume except the last block, right? Yes. So we can increase or decrease the block size, right? We can configure the block size. Configuring block size, right? Yes. Configuring the block size means configuring means increase or decrease. Increase or decrease, right? Yes. So go to the Hadoop installer directory, right? Yes. So within this Hadoop folder, there will be a folder called etc folder, right? Within that conf folder, we have Hadoop. Within that subfolder, like etc and conf folder, within that hdfs-site.xml file will be there. It's an empty file as of now. Initially it will be empty, right? If you're not configuring anything, hdfs-site.xml. Open this file and configure. Open this file and configuring the following, right? So XML file means we need to create our own tags, right? Configuration, 1 second. Configuration, right? Opening and closing, right? Configuration, open and close. And within this configuration, there is one more tag called property tag, right? Property, opening and closing, right? Yes. Within the property, name and value. Property name. dfs.block.size, right? Slash name, slash value. If you want to increase or decrease, right here, say just to say 90 MB, 90 MB. I'm just setting to 90 MB or 100 MB, right? Yes. 100 MB. I'm just slash value, right? Default block size is 64 in the previous versions. So I'm just setting my own block size, right? Default block size now 100 MB. Now the data will be divided into fixed size block. Each block will be of 100 MB, right? 100 MB. Just we need to say 100 M. That's enough, right? If you want 150, 150. Okay. So that's it. This small configuration file we need to set. Configuration property. What is the name? Name is DFS block size. Value is this. This is one property. In the same way, if you want multiple properties, if you want to set, you can set multiple properties, right? Yes.
I have a question. If you have to set multiple properties, the name value will come within the property, or it will be another tag like property and close property.
This is one property, right? One more property and slash property will get.
Okay, one more we have to create.
But every one, yes, one more property name value you will get.
Okay.
How exactly data stored and processed, right? Yes, just observe. I'm going to discuss some cases here. 1 second. Case 1, observe this case 1, right? If the number of blocks you are dividing, right? A file divided into number of blocks. Number of blocks is equal to number of slaves, number of systems, number of slaves. Full parallelism, right? We achieve high speed. Okay. For example, number of blocks equal to 4. Number of slaves equal to, okay, 4. f1.txt. Think, assume this is the file. The size is like 260 MB. Number of blocks. File size by default block size. Default block size. Okay. File size is 260 by default block size. Assume it is 64. So make it like 230 MB, right? 230, right? Okay. 4 blocks. This divided into 4 blocks: B1 block, B2, B3, and B4. Assume you have got some lakhs of 10 lakh records in this, 10 lakh records in this, 10 lakhs in this, 10 lakhs in this. Assume. So how these blocks are going to get distributed, right? This is the master node, and these are the slaves. 1, 2. Slave 1, slave 2, slave 3, slave 4, data nodes. So B1 block here, B2 block here, B3 block here, B4 block here, right? Yes. And here, this is the name node, master node. We call it as name node. Stores metadata. Stores what? Metadata. Metadata means data about data. It won't store data, actual data, but data about data. Master node, name node, right? It stores metadata, data about data. So here, name node f1.txt, right? f1.txt. into how many blocks? B1, B2, B3, B4. B1 in S1, B2 in S2, B3 in S3, B4 in S4, right? S1, S2, S3, S4. S1, S2, S3, slave 1, B1 block in S1, slave 1, B2 in S2, B3 in S3, B4 in S4. So this is how data stored, how the file divided into blocks, depending upon that file size, the default file size, number of blocks, how the blocks distributed across the slaves. This case one, if number of blocks and number of slaves are equal, assume, right? Okay, now see this. For example, data processing. Your job is to process this f1.txt. So job divides into tasks. Always your job is going to be divided into tasks. How many tasks? Number of tasks means in Hadoop, always the number of tasks depends on number of unique blocks. Number of tasks always depends on number of unique blocks. How many blocks? I'm saying the word unique. You will come to know in the coming examples, right? Why I'm saying the word unique. Four blocks, right? Means so four tasks. T1, T2, T3, T4. Four tasks because four blocks, right? So your job passes f1.txt into four tasks. T1, T2, T3, T4. T4 for executing T1 task is for executing what? B1 block, right? T2 task is for executing B2 block. T3 is executing for, it is for executing B3. T4 task is for executing B4. Now B1, it has got some, assume this block 1 has got some 10 lakh records. It has got some 10 lakh, it has got some 10 lakh, it has got some, assume. Now who should, which slave need to execute this T1 task? T1 task should be executed by which system, which slave? Try to answer.
S1.
Yeah, only S1 only, right? No other choice. S1 only should execute a T1. Why S1 only executing the T1? Because this B1 10 lakh records present in slave 1 only. So slave 1 only should execute. For example, if I take a label example, if I have got a job, I'm dividing into 3 tasks, T1, T2, T3. I need to assign to 3 students, right? T1, T2, T3. T1 task. So here student 1 is from mathematical background. Student 2 from physics, or student 3 from chemistry background, right? So if any mathematics, so here T1 task is for executing mathematical task, T2 for physics, and T3. Okay. So here student S1, S2, S3. So here T1 task, I need to assign to this student only, right? There is no other choice because this task is related to mathematics. T2, I doesn't have any choice. I need to assign to this S2 only. T3 also to S3. There is no other choice. I need to assign to that particular, because here in our example also, like B1 10 lakh records is within this slave 1. So T1 task to be executed by S1 only. T2 task by S2 only. T2 is to execute this B2 10 lakh records, right? 10 lakh, 10 lakh, 10 lakh. And T3 task need to be, who executes the T3 means S3. T4 by S4. So here if you observe, T1 by S1, T2 by S2, T3 by S3, T4 by S4. Means 4 tasks are executed by 4 slaves parallelly. 4 tasks are executed by 4 slaves parallelly. So here T1, T2, T3, T4 are executed by 4 slaves. 4 slaves S1, S2, S3, S4 parallelly. So no task is in the waiting state. No task is in waiting state. Full parallelism, right? High speed you can see here. This is case 1. If the number of blocks equal to number of slaves, both the blocks and slaves. In that case, high speed you are going to achieve 9 time. But assume this case 2, right? Observe this case 2. Case 2. Number of blocks greater than number of slaves. Assume you have got 4 blocks. Think you got only 2 slaves. Blocks you have got like B1, B2, B3, B4. You got only 2 slaves. I got a file. The file size like 230 MB, right? Number of blocks into how many blocks? 230 by default block size. 4 blocks. B1, B2, B3 and B4. How these are going to be stored across this cluster, right? So think you got only 2 slaves, S1 and S2. Slave 1, slave 2. This is name node, stores the metadata, right? So here f1.txt into how many blocks. So the entire information will be available with the master node B4. So here B1 stored here, B2 here, B3 here, B4 here. So B1 stored in slave 1, B2 in S2, B3 in S1 again, B4 in S2. So this data, this information will be available with the master. Now processing. Job is to process this f1.txt. Yes, number divided into tasks. Always divides into tasks, right? How many tasks depends on number of unique blocks. How many blocks here? 4 blocks. Means how many tasks here? Number of blocks always depends on number of tasks always depends on number of unique blocks. T1, T2, T3, T4. So here job is to process f1.txt, right? T1, T2, T3, T4, right? For executing B1, T2 is for executing B2, T3 for B3, T4 for B4. Who should execute this T1 task?
S1,
S1, T2,
S2,
T3,
S1, S1.
S1 and T4 also by S2.
S2.
S2, right? So assume like here, if you observe, S1 is S2. S1 executing T1 task and T3 task. S2 executing T2 and
T4.
here assume S1 in S1 slave 1, assume the first task 1 is getting executing. In S2, T2 will be executing. What about the other task T3?
It will wait for completing T1.
Waiting state. T4 waiting. Means here two tasks are in the waiting state. Here two tasks are in waiting state. Assume here I have taken a small file and I have just explaining you, right? Think that you have got 40 slaves. You got 80 blocks. 80 blocks means 80 tasks. 80 tasks assigned to 40 slaves. Each slave, how many tasks? 2 slaves, right? Means how many tasks will be in the waiting state in that case?
20.
40.
40 tasks will be in the waiting state. 40 are executing, right? Once the 40 slaves executes the 40 tasks, then the next 40 tasks are going to get executed, right? Means if each task taking 1 hour, total number of hours for completing all that 80 tasks,
80.
2 hours, right? First 1 hour, the 40 tasks get completed by 40 slaves. Next 1 hour, remaining 40 tasks executed by 40 slaves. But I want within 1 hour,
We have to increase the slaves.
you need to control the parallel processing. You have to control the parallel processing. Means controlling means increasing the parallel processing by increasing the number of slaves, right?
Yeah.
Okay. So here 2 tasks are in waiting state, 2 tasks are executed. Once these 2 tasks are finished executing, then it will execute the T3 and T4. So here we see less speed, right? Here less speed, less slaves, less speed. Okay, now observe this case 3 now. More blocks or multiple blocks, only one slave. But only one slave, that is S1, right? No parallel processing. Okay. F1.txt file. Assume it's 230 MB. Number of blocks is divided. Always files divides into blocks. 4 blocks. B1, B2, B3, B4. How they are getting stored, right? This is the master node. Only one slave node, right? Yes. F1.txt. into how many blocks? P1,
B2,
B2,
3,
P4. Where B1 stored?
S1,
B2,
S1,
B3,
S1,
and B4 also in
S1,
B1, B2, B3, P4.
and B4.
Data processing, right? Yes. It is divided into number of tasks. Into how many tasks it is divided, right? It always depends on number of unique blocks, right? I'll say why the word unique right here. Okay. Here, how many unique blocks? 4.
4.
4 means how many tasks?
4 tasks.
T1, T2, T3, T4. Who should execute this T1?
S1,
T2,
S1,
T3,
S1,
T4.
S1.
So here, all the 4 tasks are executed.
S1,
All the 4 tasks are executed by 4
S1.
slaves. Sequentially, one after the another. Sequentially, one after another. So here, no parallel processing. Here, no parallel processing. Sequential execution, right? Okay. Understood this case 3, right? Yes. Yeah. If I go back to this case 1, right? Okay. So that is what 3 cases, right? If number of blocks equal to that, if blocks are more, less speed. If blocks and slaves are equal, high speed, full parallelism. If blocks are more, slaves are less speed. Okay. If only one slave, no parallel processing at all, sequential processing is going to happen. So here, T1, T2, T3, T4. If I go back to this case 1, right? T1, T2, T3, T4, executing 4 blocks, right? B1, B2, B3, B4. B1 10 lakh records, B2 10 lakh, B3, B4 10 lakh records each, right? 4 tasks are executed by 4 slaves parallelly as their machines, right? If any one slave goes down, assume that this S2 is gone, S2 is down, right? 2 things you can observe here, right? 2 things you are going to observe. First is the data loss. 10 lakh records are lost. Secondly, this T2 task is failed. T2 is failed means the entire job also, that job also failed. So how Hadoop is able to overcome this kind of situations, right? When multiple tasks executed by multiple slaves, suddenly if any slave goes down, task of that slaves will be assigned to any of the. Okay, observe this. How Hadoop is able to overcome this kind of like task failure you are observing and your data loss. 10 lakh records are lost means if it is sensitive data, there is a huge loss, right? Now, replication and fault tolerance mechanism, right? Replication and fault tolerance. Replication and fault. Replication means
Duplication of the
yeah,
master copy.
duplication. Default number of replicas. Default number of replications.
Three.
Default number of replications, right?
3 times. 3 times of a master node.
Replicas. 3. Default number of replications.
3 times
Replicas
of
equal
master
to
node.
Is my voice clear and audible to everyone?
Yes, it's clear.
So default number of replications in Hadoop, default number of replications or replicas equal to how many? 3.
3 times.
3, right? Only 3. Okay. Replication means duplication. This replication or duplication you are going to apply to the file or blocks.
Blocks.
Observe this to understand this replication and fault tolerance. Please go into mute everyone, right? Replication and fault tolerance, right? f1.txt file. The size, assume it is 192 MB. Number of blocks, 192 by 64. Exactly, we'll get 3 blocks, right? 64, 64, 64 is 192. Okay, 3 blocks. B1, B2, and B3. Means here replication is applied on the blocks. B1 replicated by 3 times, B2 replicated by 3 times, B3 replicated by 3 times. Totally how many blocks? 9 blocks. How these 9 blocks are going to get distributed across this master and slave, right? Yes. Okay, 3 slaves, right? Then name node. f1.txt divided into 3 blocks, B1, B2, B3. Yes. B1 stored by S1. Okay, observe here how these 9 blocks are going to get distributed across this 3 slaves. Only 3 slaves are there, right? How these 9 blocks are going to get distributed across these 3 slaves. Okay. B1 block here, B2 block here, B3 here. Again, B1, B3, B2, B3, B1, B2. B1, B2, B1, B2, B3. Okay, see this 9 blocks are distributed across this 3 slaves, right? 9 blocks distributed across these 3 slaves. Okay. So B1 block stored in S1, S2, S3. B2 also in S1, S2, S3. B3 also in S1, S2, and S3, right? Fine. Next is this how data is stored and how these blocks are distributed across the slaves. Now, so here job divided into number of tasks, right? Number of tasks equal to number of
Unique blocks.
unique blocks. Here how many blocks?
9 blocks here.
Unique blocks are
9.
3 blocks. Unique blocks are 3. 9, not 9, right?
Yeah.
Observe only 3 blocks. Remaining 6 blocks are duplicated blocks, duplicated.
Okay. So we don't need to consider duplication blocks. We have to consider only main blocks.
Unique means what? Unique blocks means 3 blocks only. B1 replicated by 3, B2 by 3, B3. But at originally B1, B2, B3.
And B3.
Unique blocks.
Okay.
You replicated for 3 times, 3 times, 3 times, 9 you got.
Okay.
Why are we replicating here?
Just 1 minute. I'll complete this. You will come to understand, right? Why this? So now you got unique blocks, right? Okay. So T1 task, T2 task, T3 task. Now job is to process f1.txt. Yes. T1 task, T2 task, T3 task. T1 for executing B1 10 lakh records, B2, T2 is for B2, T3 is for B3. Now try to answer everyone. Who should execute this T1 task?
Slave 1.
Slave 2 cannot execute it.
Slave 2 can also execute.
It can also slave 1, slave 3.
All 3 slaves are executing.
Save slave 1, slave 2,
Slave 2 and slave 3.
slave 3. Slave 1, slave 2, slave 3. Slave 1, slave 2, and slave 3. Just 1 second. Give me a second. So T1 task is to execute P1 10 lakh records. So S1, S2, S3, all these three can execute it, right? Yes. T2 also by S1, S2, S3. T3 also can be executed by S1, S2. Assume all are eligible. For just I was saying a labor example like previously. So if job T3, three tasks are there, student 1, student 2, student 3. Student 1 knows only maths, it's a mathematical background student. Student 2 physical, chemistry. But what if S1 student knows maths, physics and chemistry? S2 also may knows maths, physics and chemistry. Maths, physics and chemistry. T1 task I can assign to any of these three students, right?
Yes, we can answer. We can answer.
Yeah, you can assign this T1 task to S1, S2, S3 to any of this. Okay, fine. Answer. Okay, fine. Yes, coming back to our example, right? Yes. So here also T1 task S1, S2, S3, any of the system slave system can execute. T2 also, T3 also, right? But assume the master node has selected for executing T1 task, master node has selected S1 only. Assume it has selected S1 only. For executing T2 task, master node has selected S2 only. Assume. For T3, it has selected S3 only, right? Yes. Now observe. T1 task executed by S1, T2 by S2, T3 by S3. When this T3, when this three tasks T1, T2, T3 executed by S1, S2, S3, when these three tasks are executed by the three slaves S1, S2, S3, suddenly if any slave goes down, right? Do you think there is any data loss here?
No.
Previously, T2 task is to execute B2, right? B2 still present in S1, S3, right? Is there any data loss if that slave 2 goes down?
No, no. Because we have a replication of T2
Yeah.
task for T1 and T2, T3.
Previous example, right? Without replication, if slave 2 is down, 10 lakh records were lost, right?
Yes, sir. That moment we can lose the data.
We
Without
lost the data.
replication.
You lost the data. Now there is no data loss, right? Just now you asked, right? Yes. Why replication is required? Why replication is required? You asked, right? There won't be any data loss. Yes. Fatima, have you understood now?
Yeah.
So why replication is required means even though if any slave goes down, still if slave 3 also is down, assume slave 3 also down, right? As they are systems, still there is any data loss.
No.
Still all the data is available in S1, right? There is no data loss. That is first one. Second is the task T2, can it be done by S1 or not? S1 or S3, can they execute S1 or S3? S1 can execute this T2 task, right? Because the T2 task is for executing B2, or even S3 also can execute that. But if any other slaves available, so the T2 task can be, so there is no data loss. That is first. Second is the task is not fail. Task won't fail. The T2 task will be assigned to any of the other slaves, S1 or S3, S1 or S3.
Vijay, I have one question, Vijay.
Yes.
This replication will take automatically or otherwise we have to do manually?
Yes, 1 second. The default number of replications are 3. Even we can configure increase or decrease, right? By default 3. If you're not specifying anything, by default 3. Just now I said, how did you configure the block size, right? To
Yeah.
the same way you write one property for how many replications you want, 3 or 4 or 5, depending upon the sensitivity of the data, right? So if you're not specifying anything, by default it takes 3.
Okay.
Provided that if you have got 3 slaves minimum.
On occasion of replication, it will take. I mean, it will goes to automatically. Otherwise, we have to mention again. I mean, if I have multiple slave IDs, not like 3. If I have many, I have like 5 and 6, and the blocks are less than the 6 nodes, it will take. It will goes to automatically to other slaves, or we have to assign again.
If for example, here 9 blocks, 3 slaves are there. They are
Okay.
distributed among these 3 slaves. Okay. If for example, 4 slaves are there, 9 blocks. What happens?
Okay.
They are going to get distributed across the 4 slaves. Means 9 blocks means into 4. 2, 1 will be getting 3, right? 2, 2, 2, 1 will be getting 3. Otherwise, one will be getting 3, one other one will be getting 3, 3, 6 plus 1, 1 in this. The distribution, right? They're going to get distributed across the slaves. Depending upon that, so everything the master node will have the total control over the slaves, right? Yes, will have, right? About that storage, what is the storage level? Whenever any request is made, right? Any storage or processing request, first it will check the first it is going to check many parameters before it actually going to store, right? Space availability check, number of slaves required, what are the number of blocks, whenever there is any storage request, whenever there is any processing request, right? So first it is going to check some parameters before it is going to store, right? But here what I am trying to say is, even though if a particular slave goes down, there is no data loss, there is no task failure. So that the task is assigned to any of the other slaves, right? This process is called as fault tolerance mechanism. This process we call it as fault tolerance mechanism, like this. Here I got some couple of queries, right? Here T2 task, here T2 task assigned to which slave, S1 or S3? Which one? And that is 1. While assigning the task T1, why the priority is given to S1 only? Why not to S2 or S3? Is there any criteria followed in assigning the tasks to the slaves, or randomly any? Assigning the T1 task to the slave S1, why the priority given to S1? Why not to S2 or S3? What is the criteria followed here? If any slave goes down, then the task T2 need to be assigned to which slave, S1 or S3? What is the criteria followed here in assigning the task to the slaves? Either in the slave failure or while first time assigning the task to the slaves. Observe here. Slave 1 executing T1 task. Slave 2 T2 task. Slave 3 T3 task. Suddenly slave 2 is down. Then T2 task equal to S1 or S3? To which one? S1 or S3?
Depends on if S1 or S3 is complete or close to completion.
For example, 3 students you are assigning task, right? Why you are giving priority to student 1? You are giving the task to student 1. Why not to student 2 and student 3? They are also
based on the response and processing time.
So already I am the master node, right? The students are the slave nodes, right? I already know the capability of each and every student, right? So if I give the task to student one, is going to complete in the, I'm going to get that response faster, right? So that is what here also the same criteria followed here. So here 4 steps criteria here, while assigning tasks to the slaves. 4 steps criteria is followed. 4 steps criteria is followed. First one, master node selects the slave which is highly configured, highly configured means which has good hardware configuration. Master node selects the slave which is highly configured among those. S1 and S3 which has got good hardware configuration, that will be selected, that will be given the priority, right? If assume if both are highly configured, then same configuration, if both are highly configured, then as you said, right? Yes, you have said master node selects the slave. Master node selects the slave which is more ideal, that is more free. Assume if both the slaves are free. Assume if both the slaves are free, then if both are free, then
Random, maybe.
not after 4 steps only, it will go to random. Master node selects the slave which is nearest to it. Think that all the slaves are master and slaves are maintained within the same lab. If both the slaves are equally near, then master node selects the slave, the master node selects the slave which has a good health status. Good health status means if master node both are highly configured, both have same configuration or equal configuration, but doesn't mean that both will have good health status. Now and then one particular slave is down because of some hardware issue, some issues will be there in the hardware level, the other things, right? So which has got master node selects the slave which has good health status. If both have good health status, then in the extreme case, it selects any one slave randomly. So this is what the internal criteria follow. It won't assigns the task randomly, but generally in the second step itself, this will be assigned which is more ideal, which is more free, or which is highly configured, or which is nearest, right? Okay, this is what the criteria followed, right? So what do you mean by fault tolerance mechanism? What do you mean by fault tolerance?
Which I had one question on replication.
Yes.
Can you scroll up a little bit? Or maybe it's in the print screen, paint screen, sorry.
Okay.
Okay.
It's not
When we are replicating, right?
One second. Yes, this one.
So when we are replicating, right, that means we are saving one copy of the data, correct?
Mhm.
So the space should be available. It's occupying space
Mhm.
here.
Mhm.
And is that not a drawback?
Drawback means
Space is occupying, and I think one of the node, it goes down, one of the slave goes down, then it will assign to the other task. Here I think the processing time will also increase comparatively, right?
processing time won't increase here. Processing time will be the same. Means there it's not going to process all the 9 blocks, only 3 blocks only, right?
Yes, it is trying to do 3 tasks. Okay, it's
Three
trying.
three
One of the
tasks.
tasks is failed.
Three
One of
tasks.
the tasks
One
is
task
failed.
is failed means again okay. You mean to say S1 need to execute 2 tasks.
Yeah.
S1 or
So if
S2 need
S1, if the task is taking 1 hour, right? So if all the slaves are active, it will complete in 1 hour,
see
right? 3.
one thing instead of data loss means it's a bigger headache, right? If
Yeah,
10
that's
lakh
there.
when 10 lakh records lost for example, if it is a banking data, 10 lakh records means huge loss, right?
Mm.
And if the task is failed, the job is failed, means again it's a, okay,
Rerun.
instead of that here, okay, it may take little bit time more because of a slave failure, right?
Yeah. Now that's
Or
what I wanted to ask. Like,
but
does it increase the processing time
but
a little bit?
but here think that I got 9 slaves. Think that I got 9 slaves. Nine blocks stored in 9 slaves, right?
Mm.
Here 9 blocks are going to be distributed across 9 slaves.
Mm.
If S2 is down, S5 will be ready immediately, right?
Mm.
Means S1, S3 and S5 running parallel, right? Immediately.
Mm.
They won't be any means processing
They
time.
won't be waiting. Yes. In that
Understand?
scenario, yes. Yeah.
If you got less slave, anyhow you are processing, you will have less speed, right? As example, as per the case 2, if less slaves, less speed. If more slaves, more speed. If only one slave, sequential processing. So anyhow, if we have taken 3, but if you have taken more slaves available means these blocks distributed across multiple slaves, then the processing time also won't increase.
But space is it's occupying space.
Space
That
occupying
many.
depends upon your data, if your data sensitivity, right? If data is more sensitive, then we will go with 3, or if go with 2 or 4, right? Depending upon your cluster capacity, depending upon the sensitivity, you are just going to configure the replication, right? But if your cluster is not a big cluster, you cannot go with more replication, right? And also if the data is not that much sensitive, keeping 4 times replication, it's a waste of storage, right? So
Yeah.
the only thing is, if you want, if I doesn't want my data to be lost, if data lost means you cannot bring back the data, right? That is the biggest loss, right? Okay, but if you have got if it's too sensitive data, then you can go with more replica, otherwise 2 or 3 is enough, right?
Okay.
At a time all the slaves won't be down, right? Okay.
No, Vijay, my question is, so when any slave got failed, right? So what happened to the replication factor? So we have to maintain 3, right? So we need to repair the whatever the slave failed, right? So the data has to be restored, right, in another node to
So
maintain the
here
replication.
in Hadoop, dynamic replica creation is not possible. Dynamic replica creation is not possible. Means every time it is not possible to maintain 3 replicas. For example, if S2 is lost, right, your replication will fall to 2 times, right? 2 times replicated. If S2 is down, you will have 2 replications only, but it won't maintain 3 always. If any down, dynamic replica, but in Kafka it is possible. In Kafka, dynamic replica creation is possible, but here in it is not possible. we cannot have that, right? But still we have got other slaves, right, which has got the data blocks. So that's what, if you have got more sensitive data, then go for more replications. We can increase the replications. By default it is 3. You want, you can increase or decrease. Yes.
So after the task is complete, this replication, this replicas, this data sets will be purged, deleted. What happens to them?
No, they won't be deleted. They will be stored permanently, right? These replications. You want, if
No, the data, I mean,
yeah,
the
data
like 10 lakh records, like after processing, after the task is complete on those 10 lakh records, what happens to those 10 lakh records? We maintain those records, replicas.
replicas will be there. They are getting stored in your slaves, right? Okay, they will be available in your slaves. Tomorrow, if you want to rerun it, right? At that time, if you are decreasing the replication, suddenly if slave goes down, at that time data will be lost, right? Tomorrow, okay, in January month you ran your code successfully, your task were successful. In February, when I am trying to run this, right, you have decreased that replication to 1 instead of 3. Suddenly, if any slave went down, at that time your data will go, right? So we'll maintain if it is sensitive data, then instead of that, what I do, instead of I'll increase my slaves, right?
Oh, no, Vijay, sorry, I lost my connection. So what is the dynamic replication is not allowed in Hadoop, is it? That's what you
It's
mean?
dynamic, yeah, always 3 for example, if you are giving the 3 times replication, right, suddenly if slave goes down, at that time maintaining the 3 times replication not possible. The replications will go down, right? 2 into 2. So
Okay.
here if S2 is down, you will be 2 times replicated, only 2 times. Okay, fine. Means if you have got a 9 slaves, 9 replicas or 9 blocks are stored. If suddenly if S4 is down, right, then one of the B1 block is lost. B1 will have only 2 replications.
Okay.
And we cannot maintain also, right? If suddenly if it is there. So this replication, and one more thing, one more important thing. Whenever you configure replication or blocks, right, we need to restart the entire cluster. Whenever you modify the replication, whenever you are just configuring the replication or block size, we need to restart the server, because only once the configuration file is read, that is only at the start of the cluster, what is your default block size, what is your replication, default replication, at the start of that cluster only it reads. Once the cluster started, even if you modify, it won't reflect, right? Again you need to restart the cluster, then only it is going to take it, right? So at the start of the cluster only, what default block size I should take, what number of replications I should take, it will read. Based on that, it is going to act, right? Okay. So in the next class, I am going to discuss the architecture, right? Hadoop architecture, storage architecture, and processing architecture. Hadoop Hadoop storage and processing. And one more thing I'm supposed to discuss is, if one slave down, another slave is there. If that also down, another slave, multiple slaves are available. But what if my master node is down? Total cluster will be down, right? Because without master node is the one who is going to retrieve the blocks of a file.
Okay.
In which slaves, which blocks are available, only the master only knows, right?
Yes.
If I want to retrieve F1, the F1 blocks are stored in which slaves. That is everything available with the master, the metadata information, everything available with the master. So if master down, no storage, no process, right? So how Hadoop is going to overcome means,
Standby master is there? I mean, like a standby master?
like a master, we have got secondary master available.
Yeah.
Immediately, whenever this master is down, immediately
Second one, like a standby master will take activity.
Yes, it becomes active. There will be some heartbeat signals between them. How this secondary master comes to know that this primary master is down means heartbeat signals between them. If the signals are missing, right, then immediately it becomes active. Even between the master, how a master node comes to know that slave 2 is down? How this master node comes to know that slave 2 is down? Then only it can assign the T2 task to any other slaves, right? For master and slave also, there will be heartbeat signals between them.
In between, what kind of signals?
Heartbeat signals.
Heartbeat signals.
We say like for every 3 seconds, slave node will be responding to the master, right? If it is not responding, if that heartbeats are missed, right?
Yeah.
Then immediately it will assign that task to other slaves, thinking that the slave went down, right?
Okay.
So there will be some signalings between the slave and the master, primary and secondary, right? Yes. So more discussion of this we'll be discussing in the next session, right? So I'll be discussing about the architectural part, what happens internally. So first 4-5 days only you will see some kind of theory, right? Once we enter into the practicals, there won't be any theory at all. Because to understand the total architectural, what is happening in the Hadoop, first 4-5 days we'll be seeing it. But once we enter, right, there won't be any theory, like everything will be shown in the practical part, right? So everything will be discussed, how this storage, processing, everything is going to happen. So okay. For the initial classes only, we see some kind of theory diagrams, right? Okay. Fine. Any other queries, anyone as part of
Yeah, for the next class on Monday or Monday?
next class will be on Monday.
Okay.
The next class is going to be on Monday, right? Yes. Okay. So tomorrow Saturday there is no class, and tomorrow at 5:30 p.m. I'm starting. It's a weekend. There is a batch called PySpark. Spark with Python implementation, right? Spark with Python implementation. It's a weekend batch. Saturday 2.5 hours. Sunday it will be of 2.5 hours. So in a week you will be getting 5 hours, right? Monday to Friday. That 5 hours taken on Saturday and Sunday. That is Spark with Python implementation. Tomorrow at the evening, in the evening 5:30 p.m. right? You can just see in that DURGASOFT website, right? The link, everything is provided. You can just follow that link if anyone wants to interested in Spark with Python implementation. Prerequisite only is Python. You need to know the basic knowledge of Python, right? Tomorrow, Saturday and Sunday, both at evening 5:30. First initially 5:30 to 7:30. That's today, tomorrow, and day after tomorrow. Yes. Fine. But our Hadoop session next is going to be on Monday, right? Yes. Continuation what we have discussed, right? So any other queries, anyone? Right? So I'm stopping here for today. We'll meet on Monday again. Same time. You can follow the same link. And Monday, okay. Monday also you can attend the session, right? But from Tuesday onwards, the link is going to change, right? Means those who are enrolled with that and those who have got registered, right? Only those people will be getting the link to your mail IDs to join that.
Okay.
And those people will be getting the notes videos, right? It's okay, fine. Okay, so I'm stopping here. We'll continue on Monday.
Okay.